guys, welcome back to Program with Sam, and today is Java Lesson 4. So up until now, we've been looking at creating pure classes, or classes that have a singular purpose or function. For example, the file handling class that can read and write files. And for the most part, they've had no real use in any application aside from the file handling class, which allows you to read and write to files. However, it may be the case that when you're developing your application, you have classes that are very similar in nature. And some of them may even have exactly the same functions. Some of them may be near enough indistinguishable aside from one or two fields. And in this case, it may be that you actually want to use abstraction and inheritance, or at the very least, inheritance. Now, what this allows you to do is to declare an abstract class which could have all of the necessary fields and abstract declarations of the functions, or just full-on implementations of the functions, and then any classes that inherit from that class will have access to those fields and functions in some way, shape, or form, depending on your access modifiers. So, for example, let's create a class vehicle. We're going to make an abstract class, and we're going to call it vehicle. So in IntelliJ, you do this the same way as a normal class, but you put the keyword abstract up in there. Now, what do we think a vehicle is going to have? A vehicle is probably going to have a number of wheels. So we might do public, or let's do protected. Protected int num wheels. We could say protected int num seats. And we could do protected int top speed. Now, what else might this vehicle then have? The vehicle may then have a constructor that has int num wheels, int num seats, and int top speed. So that would just set up an abstract object. Obviously, you can't technically initialize abstract objects, but we can call the constructor in the constructor of our other objects to set these values. What else may a vehicle want to have? Maybe nothing for now. Maybe we'll leave it like this. We have our vehicle class. But then if we decide that we want to create a new class, let's say car, and this is going to extend the vehicle class because a car is a vehicle. Create constructor. And so essentially this car is just going to call the constructor of the vehicle, but maybe cars have something else, like a public int or protected int num headlights. And then we can add to our constructor here int num headlights, except we have to do it the other way round. So doing it the other way around because it needs to instantiate the object first and then set our variables for this particular object. Now what that means is that the car is extending the vehicle, but we could also have perhaps a lorry if we want a lorry. And we can also say it extends vehicle, and we can say protected int num headlights. Like that. We'll create the constructor, pop, and we'll add int num headlights. This dot num headlights is equal to num headlights. But maybe the lorry will also have a protected double max weight, because lorries will be hauling around freights. So maybe we'll have then a double called max weight, and we'll just say this dot max weight is equal to max weight. Now, one thing that you might notice is that car and lorry both have number of headlights. So what if instead of having vehicle, we had another abstract class and we called it motorized vehicle? And this could extend vehicle. So it would have the same constructor, but we'd have protected int num headlights. And then in here, we put int num headlights. And again, we put down here, this.numHeadlights is equal to numHeadlights. But what we could do now is we could change car. We could change it from vehicle to motorized vehicle. And in this instance, we then pass numHeadlights to it there, and we can get rid of this entire line of code and the variable in car. Similarly with lorry, we can then do the same thing. So instead of that, we'll do motorized vehicle. We'll put numHeadlights in there. We can remove that code. And the only difference between lorry and car then is the fact that lorry has a max weight. They both inherit from motorized vehicle to get the numHeadlights, and then that inherits from vehicle, which means we could essentially add another class. We could add another class called, or do we want to make this abstract as well, actually? If we make them both abstract, that's better. There we go. We can make another class, and we could call this manual vehicle. And if we set that to abstract as well, it could have potentially, let's do object power method. So whether it's going to be pedal power or something else. And you could then have a manual vehicle with a constructor int. Oh yeah, we need to extend vehicle. Extends vehicle. And then if we get rid of that, it will complain that there's no constructor. Perfect. Power. This.power method is equal to power method. And we'll just put an object power method. And that's just an arbitrary example, but it's a differentiation between the manual vehicle and the motorized vehicle. And in this instance, we could then say a new Java class and call it bicycle. And that could extend manual vehicle. And then if we just include this, there we go. And the bicycle then has, you know, everything that a manual vehicle does. But they're all extended from this main vehicle here. All of these classes are derived from it, which means all of these classes have access to the same fields in there. For instance, if we go into bicycle and we say this.numSeats, we can access the number of seats it has all throughout this class. And that's one of the uses of abstraction and inheritance, is the fact that you can essentially reduce the amount of code that you're going to have to rewrite. All of it can be done through abstract classes and then inheriting through those classes to create, in some cases, huge hierarchies. And what I'll try and do is I'll try and overlay a class diagram here now. So here's a quick example of a class diagram, and it shows our classes that we've declared here. We have the abstract class vehicle, of which the two classes, motorized vehicle and manual vehicle, are inherited. On top of that, we then have the three actual classes, car, lorry, and bicycle, which inherit from motorized vehicle and manual vehicle, respectively. And that's an example of how you can plan your class structure or how you can display it to other users and other developers. Another important thing to remember, though, is that access modifiers are very important, particularly when it comes to abstract classes, inheritance, that kind of thing. For instance, if we now go to vehicle and we change these to private, aside from setting them in the constructor, other classes are not going to be able to access them. You see, they can't access any of the ones from the vehicle base class. So it's important to bear in mind when you're doing this kind of stuff that you need to think about access modifiers and whether you want them accessible like this. If you want them private, you can just do public functions for getters and setters, as we've seen before. By this point, we've examined the uses of abstract classes in the terms of code reuse, but there are others. For instance, abstract classes allow for the external loading of classes at runtime. So for instance, if we have an abstract class called vehicle, we could, in theory, through a process called reflection, allow users to write their own vehicle classes, which would then run at application runtime. Now, the benefits of this means that you could essentially have you can make framework applications, and then users can write their own things to execute inside your application space, inside your framework. One example of this would be an example would be Hadoop, for instance. So Hadoop allows you to write your own MapReduce jobs, which they will then run inside their Hadoop framework, which will run on multiple clusters of nodes, and then will deliver your results to you. But all you have to do as the user, aside from setting up the framework to begin with, is writing the job file, compiling it, and then executing it in their framework. All of the heavy lifting, all of the actual sciencey stuff is done for you. You're literally just writing, a block of code. That's one of the uses of abstraction. Similarly, this could be, could be done using interfaces. They're an interesting type of Java class, and we'll be looking at them next time. So just keep abstract classes in mind as we go through them, because you'll notice some similarities, but you will notice some differences as well. And then we'll sort of examine the question, why use interfaces over abstract classes, or why use abstract classes over interfaces? The short answer is it's probably dependent on what you want to do with them, but we'll examine that closer to the time. So abstraction and inheritance are both key elements of object-oriented programming and design. The idea that you can minimize the amount of code you have to write by organizing your classes into a hierarchy has been an interesting area of programming since its inception. The concepts are pretty much commonplace nowadays, so if you're unfamiliar with any of them, there's loads of material online for you to go through. If you really want me to go through it with you, leave a comment and I'll consider making a video for you. But it's a very common practice nowadays, and I strongly advise that you get to terms with it, because many languages are object-oriented now. You've got C++, which is essentially an object-oriented extension for C. You've got Java, which is an object-oriented language. You've got C#, which is object-oriented. You've got Python, which is pretty much entirely object-oriented. But now that we have these abstract classes and these bicycle, cars, and lorries and stuff, how does that actually help us? Well, if I make a new class, and I'm going to call this one main again, and we're going to declare a main function. What we can do is we can create an array list of vehicles, and we'll call this on the road is equal to new array list. So obviously we've got an array list of vehicles, not an array list of bicycles or cars or lorries, just vehicles. Now what this means is that we can take any object that is of type vehicle, and any sub-object, so any subclass of the vehicle class is treated as a vehicle. So that's an important thing to remember if you're doing class checking, is if you are checking for a specific type of class and that type is the abstract class, it will auto return true if the class is a subclass of that abstract class. Now what that means is that you'll encounter a problem if you're after specific classes before you default to the abstract class, for instance, or if you're searching for a specific subclass of a given class, because you'll encounter problems where it will return true even though it's not technically what you want. If v instance of vehicle outputs system.out.println, we'll say v.getClass plus what is instance. So for now we're going to go through all of those vehicles in that list, and we're just going to tell you which ones are vehicles. Now we know for a fact that they're all vehicles, so in theory all of them should return as vehicles. Did I not do that right? Application main apply. Yes, there we go. Run. So it should say abstraction.car. Yeah, class abstraction.car is instance, lorry is instance, bicycle is instance. So what happens if we change this to bicycle? We should then only get bicycle as instance, which we do. Now, what happens if we want just motorized vehicle? In that instance, we only get car and lorry. And so this is what I was talking about earlier. This is where it becomes important to make sure you get your order of checks right. Because if we search for motorized vehicle, but we actually want car, we'd want to search for car before we search for motorized vehicle. Now, the reason for that is because if we want car and we've gone motorized vehicle, we're going to get lorry as well, as we just did. So we'd have to check for the subclass of car before we check for motorized vehicle. I hope that makes sense. Please let me know if it doesn't. Next time we will be looking at creating enumerators, demonstrating the uses of enumerators, creating interfaces, and demonstrating the uses of interfaces. If you could follow me at ProgramSamBlog or follow the blog directly at programwithsam.code.blog, that would be much appreciated. And I'll see you in the next one.